Yeah, just a moment to have all of the technical stuff. Yeah, should be good to go. So happy to be here. Actually, Turku has a special place in my dev heart, so to say. My professional career in software development started actually here, right around this area, if I am not completely mistaken, or somewhere around here. Well, you know, wherever university is located, I get a bit confused with the geography, but somewhere not too far from here is where I got my first dev job here at Turku. But I'm not here today to talk about that, and not at least too much about myself. I'll get into a bit of further details in just a minute, but I am talking about refactoring with stratified design. And you might be scared right off the bat with those two scary words up there. First of all, stratified, and second of all, refactoring. Well, let's start with the refactoring ones. I suppose most of you know the basic meaning of refactoring, which means basically changing your code without changing the actual functionality. Well, ideally this talk would be just called stratified design. And that would be in the ideal world where we tend to deal with new code bases. We could always start from a fresh sheet of paper and kind of start designing our software with nice design principles in mind. But unfortunately, that is not the case most of the time. And most of the time, we do deal with old code bases. And old code tends to be messy, tends to be hard to read. You're just trying to fix a bug or implement some minor new functionality, and you have to spend a lot of time kind of trying to figure out what does this piece of code do, what is the level of detail I should be focusing on, and so on and so forth. So the second part of the title, stratified design, I hope is something that could be a tool for us all kind of to help manage those situations when we are, for instance, digging into some old piece of code and trying to wrap our heads around of what is happening in the code. So to give you some further idea of what this talk is about, I already started giving some background, but of course some more is definitely needed. And I will actually do this by using two different examples. I will start off with a completely made up example using just fake data, fake code to kind of get the concept of stratified design hopefully more understandable. And then we will move on to a more realistic API, one that is, example, one that is based on an API in our actual client project, but one that I have adapted and modified in order to be able to use it here as an example. So we'll start off with a made-up example and conclude hopefully with a more interesting, realistic example. And by the end of the presentation, I hope you will have some kind of idea of what these strange and perhaps scary words actually mean. So I promised to give a little more information about my personal background, and it's a bit of an unusual one. I've come to coding from a linguistic background. I've studied Russian language at the university, and I can't help starting off this presentation with a small etymology lesson. I mean, that is after all what you are here for, probably. So the word stratified is a past participle form of the English verb stratify. And as you may see already, it comes from Latin, from the word stratum, as here demonstrated by this Wikipedia article. And stratum basically in today's speech would mean something consisting of layers, something layered, as you see an image of some kind of chalk, a rock there consisting of different kind of layers. And obviously when we're going to talk about stratified design applied to code, we are talking about code and layers we find inside our code. So that's the kind of basic idea of stratified in the term. But before actually going further into the actual example, we might want to ask, what is the point about all this? Why would we go on and bother with some kind of design principles? Why not just write the code and let it do its job? Well, I think the main reason are these three fellows we all kind of tend to stream for, I would say. We want our code to be readable, maintainable, and testable. And I think there is a huge difference between code that has just been written and code that has been actually designed with some kind of design principles in mind. And what is the special point of stratified design? What does that concept bring into the table? And I would say it's the ability it gives us to ignore some details and kind of have your mind focused on the right stuff, so that when you come into a code base, you kind of don't have to know all the intricate details of what this piece of code does. You can more or less just go straight into what you actually need to change. That's kind of what we hope to achieve with this particular design pattern. And one thing I do want to emphasize is the fact that I am by no means an expert in different kind of design patterns and coding strategies, but I think it's something we all share in common, the fact that we kind of often look at some piece of code and get the idea that kind of this one could use some refactoring. I mean, we read perhaps a pull request of a colleague of ours and think that there's something you should change with this code. You should make it more readable. And that's not a really helpful comment actually to have. We would like to have more kind of terms and more words and concepts to use in order to describe the gut feeling we might have about code. And I think that is actually the use case for these kind of concepts. It's to have a common language to talk about structure of code. And stratified design is just one principle you might be using, but it's a good one, I think. And the main point is to have some concepts to use when discussing code. So I promised to start off with a made-up example. And I happen to be an avid disc golfer. I don't know how many of you guys do any disc golfing activities outside. I know Turku is a big place in that sense. You got good courses and good players. So why not start off with some fake disc golf data? So here's a totally made up TypeScript dataset consisting of players, disc golf players who compete in the game of disc golf by completing holes. And ideally, these holes would be completed in either 3 or 4 strokes, which is called the par of the hole. And when the players play the game, they fill in scorecards representing the scores they have, how many strokes they used for each hole they played through. So now let's take this fake piece of data and see some fake code using that data. This is totally made up. I have not run this code anywhere, but you see there is a TypeScript function called convert results to CSV rows, which might be something that we would probably want to use if we would be using our disc golf data to kind of print out a spreadsheet of some sort of those results. So we might have a function like this, and its job would be to give us a list of scores in a CSV format or something of that sort. So let's try to take a closer look at this made up piece of code. What is actually happening? Yeah, well, the first thing I have to say is that you definitely don't get a sense of good design looking at this code, but let's try to bear with me and kind of look through what we have here. There's some kind of call to a function called getPlayersCard, I see, and then there is another function called getTotal. We've got a couple of for loops and a couple of accessing arrays by index happening here too, and native JavaScript array methods and that kind of stuff. So you do get a sense that this could use some refactoring, this piece of code. And let's see if stratified design can help us with kind of getting a better grip of this code. So as you may recall from my etymology lesson, stratified means something layered. So if we were to apply stratified design to this piece of code, we would kind of want to look for layers in this code. Now, what kind of layers does this function, if we look at the convert results to CSV rows function, what kind of layers does it have? Well, we could interpret this question in a multiple of ways, but one way to look at is this. We've got some elements of what you could call native language features. We got the for loops I mentioned, and we also have the accessing the array by index. We then have the native array methods. So that you could consider this sort of one layer inside this function. Now this one would be on a different layer, I would say. We got a rather generic function called getTotal, which basically just takes an array of numbers and prints out the sum. So that's rather abstract, rather generic compared to this one, get player's card, which is rather specific. It's specific to this domain, specific to the task at hand, and kind of specializes in getting the player's cards, obviously. So 3 broad kind of layers going on here. And stratified design lends itself quite nicely to different kind of visual representations, and the most common one we could use to represent the layers we just found is what you could call a call graph, which we have there on the right-hand side. So basically we could interpret the layers in this code in the following way. We've got the lowest layer there at the bottom which has those native array methods, for loops, array indexes, that kind of low-level stuff. Then we have on the topmost layer, we have the very specific function called getPlayersCard, and then we have the more generic functions there on the level between these 2 layers. So that would be one way to look at this function. And the idea with stratified design is that if you were to have straightforward implementations of functionality in your code, you would rather be working on just 1 or 2 layers at a time. And those layers would ideally be similar to one another. So what is going on here is that we have multiple different layers, and the layers are kind of not on par with each other. They aren't really that kind of similar layers we would like to have. So that's the first example that hopefully gets some idea about what it is we are looking at a code when we are looking at it through the lenses of stratified design. So this was the made-up example, and now I promised that we will have a more realistic one too. So this is based on a real-world project we have in our team, and we have a Node.js API which uses the Koa framework. You probably are aware, if you are in the JavaScript world, you are aware of Express as a Node.js framework. Well, Koa is a similar kind of beast. And here's a very simple API endpoint called alarms. And the goal of this endpoint seems to be that a user of the API sends an HTTP post request to the endpoint called alarms, and then we call a function called create alarms, which obviously probably creates an alarm, and then at the end we kind of tell the user if the job was successful. So pretty basic stuff. If I were to jump into this code right now with the intention of implementing some new functionality, perhaps fixing a bug, I would kind of know what to look for. If I, for instance, had to change the message we give in the response body, that would be pretty straightforward. I would know where to look for that. Now this part of our API represents newer code in our API. This is a rather recent function or endpoint which is kind of already implemented following some kind of design patterns. It's following the kind of, at least trying to follow the kind of stratified layer design I was talking about earlier. Now we do have other kinds of endpoints in the API too, and let's take a deep breath and take a look at another one, which is an older one. And this one is not has not yet been refactored in any way. You don't see a lot of code at the moment, which might be a good thing actually, because the code you're about to look at is not straightforwardly implemented. And if you were to kind of have to dig into this code, you would have to spend more time and effort. You would get the job done, which this code probably does, but you would have to make considerable effort in order to kind of find and navigate your way around the code and know what is happening where and what are the details I should be concerned about when I am approaching this piece of code. So this is an older API endpoint which has not yet been refactored. We will not go through this line by line. We will come back to that later on in just a couple of minutes, but let's first take a closer look at this endpoint we started with, the alarm endpoint, and look at this function, create alarms, how comfortably it sits there on the edge of those screens. But you probably see the point that create alarm is the function that actually has the logic for creating alarms. So let's see from the perspective of stratified design, what would that look like if we take a closer look. Now this is basically the function create alarms here. So it has a couple of lines and a large number of function calls. And if you look at these function names, they do seem rather similar to one another. We've got, again, a bit hidden there under the screen limits, a function called build model entry. We are building some entries, build analysis entry, another one there. And if we were to construct a call graph of those functions we just saw there, it would probably look something like this one here. So we've got a couple of functions here, 4 to be exact, which sort of form a layer of their own. I mean, just by looking at these names, looking at building an alarm item, building an analysis entry, model entry, and so on, you can kind of get the idea that these are sort of working on the same level and kind of deal probably with the similar kind of stuff. Then we've got a bit of an odd one out, build user ID. It definitely is not on the same layer as these guys over here, but nonetheless is a function. You probably understand what that might be doing. And then we got 2 functions on the which I've drawn on the lowest possible level. Other one for getting a next model version, and a final one for writing an alarm to DB. And these are clearly on a different kind of layer than those. But basically the structure is pretty simple. If you were to kind of look into this, you would kind of not have such a hard time navigating through what is happening where. And one nice thing about this structure is the fact that if you look at these 2 guys I just mentioned over here, they are, if you think in functional programming terms, because stratified design basically is a functional programming concept. We, as you may be aware, when you're writing, trying to write functional stuff, you want to get rid of functions with side effects, or better said, you want to isolate those functions. And this structure kind of helps us to isolate those 2 functions which deal with the database and thus have a side effect attached to them. So all in all, pretty kind of straightforward in a way. We might go one level lower and look at one of these 4 functions. Here I have build new alarm item, which seems to be conforming to this kind of structure. You see there's the actual function. It calls 3 kind of generation function, generating alarm item key, alarm item name, and then also deals with some low-level language features. If we were to take a look at another of those, now this one is a nice one in the sense that it actually demonstrates a bug I was personally dealing with a while ago. So this, as the function name says, the job of this function is to get a next version for you. Now it calls a function called run query. You kind of understand what that might be doing. It also uses a query builder library called Nex, might be familiar with that one, and uses those methods of that library in order to run some database queries. But the basic thing here is that when you've gone down to this level already on this, when you are on this layer, you kind of are expecting to have something like database calls and next library methods. So you kind of don't have to try to figure out the right level of detail. You know that inside this function we are looking at a database call and that kind of stuff. And actually we did have a bug related to this alarm functionality, which was related to the versions we were using there. We noticed that the versions were a bit off. Something started to happen after version number 9. And of course it was the classical thing that we were having a string column and ordering by that column without realizing that it was a string-based column, so we had to change some of the ordering logic there. But the point is that it was rather easy and straightforward for us to kind of find out what the bug was about and where to kind of touch. It was easy to navigate through the actual part that was dealing with versions and versions not following the right order. So this kind of structure, I think, in this particular case, definitely helped us kind of, in a faster way, navigate through the problem. And the bug was dealt with. So now, after having gone through that newer part of the API, which was kind of already using those design principles, let's try to take another deep breath and dive into the old version of the endpoint, or the other endpoint that represents some older part of the code base, which I've named just, let's go back. Well, you can't see it quite clearly, but it's called items. So we're dealing with some items in this endpoint. And let's take a look at, if we can, what is the stuff that is going on here. So this is basically on the same level as the other endpoint. This is a Koa.js route. We have a route API/items, and here we also actually already have some database calls. We are already here using the next library methods. We are fetching some data from the database, and what is happening here? We are trying to build some search terms, I guess, with these couple of filters and reducers. Then there is a for loop going on a bit further down, as you can see. A good old for loop. We need to scroll a bit more, I see. Let's have it scrolled. Come on, further down, please. Well, it doesn't go any further down, so let's just deal with the wonders of CSS, not scrolling all the way to bottom. Not too bad. We also have, not seen on the screen at the moment, but we've got some other typical kind of stuff. We got the for loops, we've got the database calls, and so on and so forth. So let's kind of try to dig in and form a structure of what kind of layers does this piece of code actually have. Now, do we have the call graph here? Yeah, the call graph is visible. So we could basically divide this particular API endpoint to the following 3 layers. There is a call, which is a bit of an odd one out. We have a call to a function there, to a function called getKey. And then we've got those database interacting methods and also the low-level language features. So that's basically the structure of this. And if we think about, yeah, it would be a good thing to have just a couple of layers. This kind of does fulfill that criterion. We kind of are not dealing with too many different layers here. Those are pretty much on the same level. We are dealing with low-level language features. We are dealing with database calls. But the problem here is, I would say that this doesn't feel like the layered rock we have there on the first slide, but rather this is like walking in a desert. You kind of just see sand, and sand looks the same all around you. You kind of would like to find some points, some anchoring points, and some layered, some structure, but you don't have that. So let's see if we could be using stratified design as a principle to kind of find those layers for us inside this code base. Let's see if the scrolling actually works or if we have to make some magic happen. well, yeah. Can't scroll through all the code, but we do see the call graph we are trying to build. So what we kind of want to do here, if we go through this line by line, would be the fact that, yes, we have our endpoint, which is kind of the basic function here. And then what we first want to do, we want to fetch data. This seems to be kind of the starting point for us. Let's fetch some raw data, and then can we see what's happening here? Yeah, if we actually take a closer look at what this function does, it seems to be building an array of different kind of items, and it's then returning those items at the end of the endpoint, which is not visible on the screen, but nonetheless kind of tries to return those. So we are concerned of taking raw data and then using that data in order to build some filtered items, I would say. So that would be represented by these two layers, I would say. We want to fetch the raw data and then filter that data. And these are kind of things that happen on the same layer. I mean, fetching the data, filtering the data, you have the same kind of mental, I would say, it's in the same neighborhood, so to say, on the same layer. Then some other stuff happening there. These rather complex lines I alluded to earlier. What is happening here actually? Well, basically, it's in one way or another trying to build some search terms. So in order for us to filter the data, we use some kind of search terms we build based on the input we get from the API request from the API user. So it seems to be the case that above these two, below these two layers, the filtering data function, which we might want to construct for this, is using a function for building search terms. What's next? What could we still find here? Well, this is something I guess it's not going to scroll all the way here. Yep, not scrolling. But what is happening later on in the code? We have the for loop, actually a nested one, which looks rather complicated and kind of scary. But what it actually seems to be doing is just checking if it's going through the data and checking if it matches the filters we just built. So basically, what we would want to have here is to have some kind of checking function that makes sure that a data item matches the conditions we just built using the not yet implemented build search terms function. And then at the very end, which also is not visible because it's at the bottom of that unscrollable thing, is that we are actually constructing and kind of restructuring the data before we are giving it back to the user. So basically, we have this bunch of code which is basically all on the same layer, and we kind of feel like we are in the desert. We don't have really good anchor points for us to kind of look forward. So what we could do is start drawing a call graph of some sort, either in our mind or just actually literally drawing it, and kind of take a look at what might be logical layers for this code to actually have. And looking at this code, these are the layers I came up with. You might have gotten up with different kind of layers, and that would be totally okay. But the main thing is to try to kind of find your way to a straightforward implementation where you have just a couple of layers interacting with each other, and those aren't too far away, too unrelevant or different from one another. So that would be kind of the way I would be going on if I were to start refactoring this particular old API endpoint. Now let's kind of start wrapping things up. What is the point of all this? What is the point of using a design pattern like stratified design? Well, as I already said, the main thing I want to emphasize is the fact that you should have some kind of principles in mind when looking at code. It might be just my background in linguistics is that I kind of want to have a good system of communication when I deal with stuff, not just kind of give the gut feelings in in pull requests and those. Not just say that this code feels kind of, it could use some restructuring or something like that, but actually have terms and concepts you can use in order to discuss the structure of the code and how it could be improved. And the main thing with this particular design pattern using stratified design would be that we are going for those straightforward implementations where we don't either have the case where we have an awful lot of different kind of layers, or the desert case where we have kind of just one layer but everything's meshed up in that one big desert of code, shall we say. And an old fact, of course, is that code is read a whole lot more often than it is written. And what we are doing when we are writing our code, when we are not just writing or designing our code, we are helping the future readers to kind of, when they are going to have to fix a bug we have implemented in our code, they wouldn't have to make so much of an effort to kind of find out what is going on. We are hoping to give them an easier job to kind of rapidly find the place they should be looking at, and not being able to ignore some details you are not supposed to be concerned at is a good thing. So as I demonstrated with the made-up example and the more realistic one, you can both kind of keep these kind of principles in mind when you are constructing something totally new, or which tends to be the case more often when you are kind of refactoring something old. It's a nice thing to have principles and concepts and patterns around to help you with those. Now, coming from an academic background, I cannot just help ending my presentation with a piece of citations and literature. It's just kind of unable to write a presentation without at least a small list. And I really do kind of think that those two books at the top, I got kind of introduced to this concept in Eric Norman's book called Grokking Simplicity, which is a really low, easy to approach level introductory guide to functional programming. And in that book, Norman cites Harold, Abelson and Sussman for the original concept. And funnily enough, Manning also they have two nearly identically named books. One is called Grokking Simplicity, one is called Grokking Functional Programming. I do think those both are excellent books, but the first one is the one where I actually got this concept from, the concept of stratified design. And below you also see all the necessary socials. I do have a blog. I tend to write at least once a month at Hashnote if somebody has any interest there about this and similar kind of stuff. But basically, that's all I wanted to say about this concept, and we do, I think, have plenty of time for any comments if somebody has.